welcome, Dominic.
Hi, I'm Dominic, and I guess I'm here to talk to you about promises in JavaScript, which is something I think I'm really passionate about for reasons I can't quite explain over the past couple of years. But I've kind of acquired a reputation as the promises guy and been involved in a lot of stuff around that. But like, how many of you know what I'm talking about when I say promises in JavaScript? Excellent, that helps a lot. So, because normally when I give a promises talk, or at least the promises talk that I have slides for that I didn't prepare last night, it's all about, here's callbacks, here's how they suck, here's the problems that you run into, and here's how promises solve them. But a lot of the stuff I've been involved with over the last year or so has been kind of, looking at promises from a fundamental abstraction point of view. Like, what do they bring to the table as a conceptual piece and as a building block for your system, and how do they fit into your overall architecture? And so I kind of structured this talk more along those lines. So, I give kind of like a ground-up approach to what promises really are, not just how you use them. And then I kind of talk about a history behind promises and recent efforts in the area. And then I talk about some kind of patterns that I've seen using promises in our systems. One other question I did want to ask. How many of you have used promises that aren't jQuery promises? All right, that is better than normal. But hopefully by the end of this talk, you'll be convinced that jQuery promises are not a good idea. So we'll see why exactly. So just a little bit about me, some of the canonical links. I have a blog now. I posted 3 or 4 posts at the top. GitHub, NPM, there's SlideShare. This will be on SlideShare within the next couple days if you want to see the slides. Things that I'm doing that I'm particularly proud of recently. So I run this account called ESDiscuss on Twitter, which summarizes, so ESDiscuss is the mailing list where kind of the members of the committee in charge of shaping the JavaScript language, and other people, just randoms from the internet like myself, just discuss JavaScript specs and how the language is going to evolve and what's going on. And it's a pretty technical thing, and it's a deluge of emails a lot of the time. So 140 character summaries pumped out every few days helps people get their heads around it. So I enjoy maintaining that account. And if you're really kind of a nerd about the language, I want to follow it. The other thing is that, and very topical, is the Promises A+ spec. And we'll talk a lot about that more later. But I think it's really cool, kind of the whole process that gave rise to that and how it's evolved recently. And finally, I'm speaking at a few upcoming conferences about a variety of topics. So in San Francisco at HTML5 DevConf, we're talking about using NPM for client-side dependencies. At Node PDX in Portland, I'm not sure what I'm going to talk about yet, but probably something about Node. And at NodeConf, I'm a camp counselor, so we're going to be talking about secret stuff that Michael won't let me reveal, because that's his process. Anyway, enough about me. Promises. So, as I said, I kind of want to give a ground-up idea of the promises abstraction. But of course, you have to start with at least one slide, and just one slide this time, on why callbacks are bad. And when you really think about it, what I mean here is that when I say callbacks are a hack, I mean that functions that accept callbacks in order to do their work are a hack. They are literally the simplest thing you could possibly do. You pass it a function and you stuff all the code you want to run after the asynchronous process into that function. You end up conflating your input and your output. Your input to a function is usually the arguments, but then you have this extra argument which is actually going to receive your output and is not really an input in and of itself. It's just a control flow construct. You lose a lot of the niceness of synchronous control flow. I mean, you end up writing callbacks that tie other callbacks together, and there's kind of this meta callback spaghetti, one callback that keeps a counter, and if that counter reaches 5, then you call the final callback because 5 of your operations completed. But it's even more fundamental than that. There's no consistency in callback APIs generally. So you could have a success handler and an error handler. You could have a success handler that receives 3 arguments. You could have a success handler that receives an error first, and then it's the 1 or 2 or 3 arguments. You don't know what's going to happen. Some of them don't even have error handlers at all. But even worse than that, there's no guarantees for how these callbacks that you pass in are going to be called, right? So somebody could call your callback 3 times, and that's kind of not what you'd expect. But there's no guarantee built into the language because we're just using the simplest thing that could literally work. And so, I mean, this is actually going to source of bugs in Express, notably, where he would call you back first with an error, but then also with the data, and people would get really effed up. Another thing that's really interesting, and I forgot to find a bullet for this, is that there's no way of handling if inside your callback you throw a synchronous error, or if inside the asynchronous process that happens, somebody throws a synchronous error, like throw new error, or say JSON.parse on an invalid string. That's usually not handled and translated into an asynchronous error as your callback argument. So there's it doesn't mesh well with existing kind of patterns like JSON.parse, which might throw an error. And finally, like one of the biggest things, and this is one that I think promises really kind of give you back in a really impressive way, is so the stack unwinding semantics of exceptions. So what I mean by that is, you can write 3 or 4 lines of code, and if any of them throw an exception, that'll hit your catch block. Or it'll bubble up to some calling function which doesn't have a catch block, which will bubble up to some calling function which doesn't have a catch block, which bubbles up until you finally hit a catch block. The kind of thing where you can defer error handling until the last minute instead of explicitly saying at every step, oh, I need to take care of this error or else throw it away, I'm going to lose it forever, is a really nice feature of synchronous code in general. So what I want to show you is why promises are kind of the right abstraction instead of the simplest thing that will work for gaining back these features of synchronous code that kind of, you expect code to only execute once when it gets a result, or to only get one result, one return value, say. So the basic idea of the promises abstraction is instead of you calling a past callback, you return a promise. Okay, I mean, that's pretty basic. But this actually has a lot of implications if these promise objects behave in the way you want. So I'm going to move through kind of the ways that they behave in a few series of slides. But first, just notice one of the benefits is that we've separated our outputs from our inputs. No longer are we passing in a function and a file name and just saying, oh, these are both inputs to the function, because they're really not. All right, so what are the guarantees you get from a promise? Well, the primary way of interfacing with a promise is with its then method. And this is a pretty complicated method when it gets down to it. But it's complicated because it needs to guarantee that your code behaves in a certain way. So there's 2 things that can happen to a promise. It can be fulfilled or it can be rejected. And only one of these 2 will be called. And the reason for that is there's a direct analogy between being fulfilled, which is like a function returning a value, or being rejected, which is like a function throwing an exception. And you notice that unlike in, say, jQuery promises, you can only get a single fulfillment value in a real promise, because you can only get a single return value from a function. You can return an array, but that's still one value. You can only throw one exception, so you only get one single rejection reason. And of course, only one of these 2 will be called. You can only either return a value or throw an exception in a synchronous function. So it's the same thing with promises. You can only be either fulfilled or rejected. A nice benefit that kind of comes into play as we look into using promises is that if you already have the promise settled, if it's already either fulfilled or rejected, then the handlers will still be called once you attach them. And we'll see how that becomes really interesting and useful later. And finally, one guarantee that you don't see in any other kind of paradigm that I've looked at is that the handlers are always called asynchronously. So if you kind of write naive callback code, you might do something like, oh, I found it in the cache. Let me call back immediately, synchronously. Whereas if you find it, it's not in the cache, you need to go off to the database. That's an asynchronous call. This kind of ruins your control flow of normal code because you don't know if your callback will be called before the next line or after the next line. With promises, these onFulfilled or onRejected handlers will always be called after the next line. They'll be called in the next tick of the event loop or later. So you get that kind of guarantee. And of course, the single fulfillment value rejection reason also gives us some consistency gains that we don't see in the naive callback paradigm, right? Because you could be passing 2 or 3 of these values. You could be passing, no errors. You could be passing separate handlers. So we're already seeing some benefits there. The next major point is that you can chain promises together. And what I really mean by this is that you can transform promises. So you get an original promise, and then you add these handlers to it. And these handlers don't only do work, right? They don't only react to fulfilled or rejected. If that was the case, we would just use events. We'd just say, oh, we have an error event and a success event. What we really want is something that can model control flow. And so this works through this transformation. So the transformation explicitly is this. One of those 2 handlers will be called. If it returns a value, then we take the return promise, the transform promise, and we resolve it with that value. And in particular, that means if we return a promise, we'll adopt the state of that new promise for transform promise. Otherwise, we'll just fulfill the promise with that value if it's not a promise. We'll see exactly how that works later. And of course, if one of those handlers throws an exception, then we reject the transform promise with that exception. So that's a bit abstract as an algorithm, but what this really enables is a very powerful analogy where it's just like a series of imperative statements. And in particular, you have this exact parallel between synchronous code and asynchronous code. So it's a little bit awkward because we don't want to do the processing if there was an error thrown. But you can see the parallel, right? You try something, you store it in the result variable. If there's an error, you handle the error. Otherwise, you process the result. So over there, that's what that says in asynchronous code. You do something, you try something, and then if there's a result, you process it, and if there's an error, you handle it. So in particular, those rules, those transfer rules, enable us to emulate kind of the four fundamental ways that functions can compose together. So we're going to go through those four cases in turn. Case one is just a simple functional transformation, right? So if you get a user and you want to get you would do transformation on that data, particularly say pulling off the name property, you just do that. You say, oh, username is user.name. In promised land, that's done with the fulfilled handler just doing that transformation and returning the result. So you get a promise for the username by saying get user, then take the user, return the username. So now we have a promise for the username, because remember, if you return from the fulfilled handler, the return promise is fulfilled with that value. Making sense? Stop me if you get confused. Okay, but this is where it gets interesting, right? So the other main things we can do in synchronous control flow is we can react by throwing an exception. So we try and get a user, but if that user is null, then we're going to throw an exception. We're in an unexpected state. And somebody else will have to handle that. This manifests in promises exactly the same way. We get the user, and then after that succeeds, we say, oh, the user is null, let's throw a new error, and otherwise we'll return the user. And what this means in particular is that the user promise will be rejected if the user ends up being null, whereas it will be fulfilled with the value of user if it's non-null. So we've done the exact same type of thing where we react to error conditions by transforming them into, in this case, rejections, whereas in synchronous code, they're exceptions. But once we have an exception, what do we do with it? Well, in the synchronous case, we do try catch. We say try, update the user. If there's an exception, then handle it, right? Log it to the console, but don't blow up the program. Don't continue blowing up the stack and unwinding all your scopes. Well, it's the same thing in promises, right? You say, okay, well, here's my promise for updating. I'm going to update the user, and then my failure handler, my rejection handler, takes an exception. So if there is an exception, I'm going to handle it. I'm not going to rethrow it. I'm just going to log it. I'm going to return undefined implicitly, which means that this promise, no matter what, will be fulfilled. Well, it'll either be fulfilled with the user or it'll be fulfilled with undefined, but it will always be fulfilled because we handled the error. Just like up here, we're not throwing an exception, or we're not letting the exception escape at all. We're just logging the error. And finally, we have the case where you rethrow exceptions, right? Whether you want to do a transformation on the exception, or hide internal security details, or turn it into an HTTP status code error, that type of thing. You get an error, you throw a new one. Same thing in promises. You get an exception and you get a rejection, you throw a new error. And that transforms the update promise into a rejection with that new error. So that's the fundamental parallel between synchronous code and asynchronous code that promises enable. And so everything else from here is kind of gravy, but it's kind of cool gravy. And in particular, we have one bonus async case. So this is not like, this comes down to that rule I said, where if you return a promise from a fulfillment or rejection handler, we wait for it, we adopt its state. Well, in promises, we can actually do that in a very natural way. Just like up here, we'd say, oh, prompt for the username, update the user, refresh the UI. Down here, we're going to prompt for the username, and then we're going to return the promise for updating the user, which means this next step will not go forward until the update user action completes. Or if the update user action fails, then, well, we don't have a rejection handler, so we're not going to refresh the UI. We're going to do nothing. So that's the kind of thing I mean when I say it adopts the state, right? the return value of prompt for new username.then is going to be the same state as whatever update user eventually does. Or it'll be rejected if prompt for new username fails. And then we'll just skip this one, right? Because we don't have a rejection handler here either. All right. So in particular, what does this mean for that case I was so excited about, the exception propagation of synchronous code? Right, so let's look at some typical asynchronous code that you might write back in your glory days as a JavaScript cowboy who thought errors were things that happened to somebody else. So you get a user, and then you get their best friend, and then you show it in the UI, and everything's happy. There's no errors. But then, you enter the enterprise, and you start doing code reviews, and they tell you, you should really handle the errors. And your code ends up looking like this. You add an error parameter using the Node.js convention to every asynchronous operation. You say, oh, there's an error. Okay, well, I better handle that. Otherwise, I can go on to the next step and get their best friend. Oh, there's an error. I better handle that. Otherwise, I can show it in the UI. Well, this is obviously really awkward. And the more levels of operations you have, the more sequential steps, the more awkward it gets. Because you have to explicitly, at every step, handle the error. Promises give you this back. Because the transformations that we've introduced allow us to just do this. We say, get the user. Oh, if that fails, well, that promise will be rejected. And so then we'll do the next transformation. Oh, but there's no rejection transformation, so it'll just stay rejected. So we'll move on to the next one. Oh, there is a rejection handler. It'll show it in the UI. Oh, okay. So any of these steps that fails, whether it be get user or get best friend, will end up in the UI.error handler. So that's what I mean when you get back exception propagation. And I think that's a pretty compelling use case in and of itself. Another nice thing, in jQuery promises, you can kind of get this if you're careful to return a rejected $.deferred. But the way that promises work, the way real promises work, is it works by throwing exceptions. So it doesn't matter what the error is, whether it's you intentionally saying, oh, I have an error, let me return a rejected $.deferred using this awkward notation, or it's you calling a method that doesn't exist, or it's JSON parse failing. All of those will get translated into errors at the end of the chain.
So is that the convention that no matter how many you chain, you just put the error handler on the last one?
I mean, it depends. You might want to intercept it in the middle and say, oh, well, if there's an error in the first 3 stages, let me handle it. Except for maybe it was a network error, so I'll let that one flow through by rethrowing it. You can always go back to synchronous code for these analogies, right? Like you have a sequence of steps, and you're like, oh, well, I need to catch an error in these first 3 steps, and then move on.
And you can go back to your success code by returning from the error.
Exactly. You can say, I've handled this, and I'm ready to go.
So in this case here, let's say, for example, you try to get Domenic. Domenic doesn't exist in the database, so that's a common error you want to throw. But then in the then, there's no error state at all in the first then, so would it not run get best friend?
Exactly.
Before you pass that until it finds an error state?
Right, because get user is rejected.
Right.
And so there's no rejection handler, so the promise just stays rejected. The return promise just stays rejected.
Right, okay, got it. And then, so it would never run get best friend.
Exactly. Yeah.
So if you wanted to do best friend, you would make an error handler in the first then and return non-error value. Yes? Or
right, like if I wanted to have like a default best friend.
Yeah.
Yeah, exactly. I could say, oh, there was an error getting his best friend. Well, his best friend is clearly Joe. So then it'll show Joe as my best friend.
Yeah.
Okay.
For that case, you'd have to do a then in the middle of the two.
You could just...
If best friend fails.
You're right.
You'd have to do a then in the middle, and to find Joe's everybody's friend, return Joe, then show best friend, do error.
You're right. Good point. Yeah, there would have to be an intermediate one. Because if you put an error handler right here, it'll only handle errors for getting Domenic.
Oh, right.
But if you put one on a line in between these, it'll handle either get Domenic errors or get best friend errors. Liking these questions shows that you guys are understanding. Cool. All right. So that's the exciting async sync parallel. Let's talk about a little bit more. Well, one last benefit I think of kind of that promises get you that's kind of outside the async sync paradigm. And this is that because promises are first-class objects, instead of these continuations we pass in as functions containing all the rest of our code, we can do some really interesting operations with them. And these operations are kind of fundamentally asynchronous. These aren't things that we could do with synchronous code even. So for example, let's say you wanted to do multiple things in parallel. Well, you fire off the get user data operation, you fire off the get company data operation. Both of those will return a promise, and they're both going on at the same time. And then we have this operator called all, and this is just a function you could write using the primitive then, that fulfills, that returns a promise that fulfills with an array of the results. So if both get user data and get company data succeed, you get the user data and the company data in an array. Or if either of them fails, then it rejects with the rejection reason. So if getting user data fails, then you get the error that triggered get user data. So whichever rejects first, you get that error. And you notice this is like, you can't really draw a synchronous analogy, right? Because you don't have a concept of like, oh, this function call finished first, so we're going to give it the error there. So you end up having like more primitives. And all is by far the most useful. But there's another one that you see sometimes that I think is useful, interesting at least, which is any, right? So let's say you wanted to store the data on 2 servers for redundancy. So you store the data on server 1 and on server 2, and you fire these off in parallel. And you'll fulfill as soon as either one of those completes. So you can move on with your program and tell the user, yeah, your data's safe. Or if both of them end up rejecting, then you get a rejection reason saying, both rejected. And again, I mean, these are just functions that I could write using then, right? You say then, oh, keep a counter. There's 2 of them that failed, so fail the promise that I want. Or fail the promise I'm going to return. And finally, and this is a really cool example. So normally, your functions just accept data, say. So if this were synchronous code, right, this would just be a file name and a chunk of data that was synchronously pulled off the file system. But let's say read file is a function that returns a promise for data, or promise for a big string, or for a binary buffer, or whatever. And write file is a function that looks at all its inputs, and if they're promises, it waits for them to settle first, and then it writes it out to the file system and returns a promise for the result. So you can get really cool code like this that reads kind of synchronously just by passing promises as first-class objects to other functions that accept promises.
Can I ask a quick question?
Yeah.
What does the all function look like then? You write that all function.
Yeah, so I've cheated a little bit by not describing how you create promises. So let's give a short answer at least. So usually there's a primitive called a deferred, which is like a promise source. So it has like 3 things you can do with it. You can get the promise off of it, and you can resolve it, or you can reject it. So you create a new deferred, and the resolve and reject control the fate of the promise property. So I'd say, okay, well, I'm going to immediately return this new promise, but then in the then handlers for arguments 0 through n, I'm going to count them up, and I'm going to say, oh, all of them succeeded, so let me resolve my deferred, and thus resolve the return promise. Or, oh, any of them failed, let me reject my deferred, and thus reject the return promise.
So I think you answered my question also. Mine was going to be to have an arbitrary number of promise returning functions going in, and you only want to keep the first one and cancel the other ones. You could resolve the first one and then reject the rest immediately.
Yes. Yeah. Well, so actually, that's an interesting point. So cancellation is kind of the operation you're talking about.
Breaking promises.
Yeah. Well, so yeah, but one of the things about promises is generally you can't manipulate their state. You're just a consumer. You can listen to what happens to them. The producer is the guy who's in control, and he gets like this deferred object, say. He gets to resolve or reject the promise. And in some cases you can say, oh, well, I'll give away this ability to reject with, say, a cancellation error to other people. But generally it's kind of a nice like encapsulation boundary to say, oh, well, I'm going to produce this promise. I'm in control. Other people can just listen. Nobody can like modify my return value or my throw an exception from my function. That'd be kind of weird.
Right. Once you fire off an HTTP request, you can't take it back.
There's actually an xhr.abort, which so.
But it behaves about the same way. The browser still does all the request stuff.
Probably.
Or the server, if the server got the request.
If the server got the request, yeah. But the browser might do like less processing.
You can't ignore it at that point.
Yeah. You can ignore it.
Well, this is actually an area that we're kind of looking into, is what's the best way to add cancellation features. Because, like, first of all, it's kind of an authority break. Like, it's saying, oh, well, we're giving the ability to reject promises to people who own promises. But that's okay. We'll accept that. What's the way to let people do that and also cancel any underlying operations? And then, if you, like, cancel a promise and chain some stuff off of it, what should happen? Should the cancellation flow down the chain? Probably. But in what way?
You might also have to extend to the server side that's receiving, like you have to incorporate the REST or something, so REST knows how to cancel something.
Yeah.
No, you really can't do that. There's so many problems with mutable state at this point.
All right, so that was the grounds up introduction of promises.
You're gonna break so many things if you start doing this. Yeah, let it finish and just ignore the result that you get back.
So what I want to take now is just a little break and talk about the promises A plus story. And what do I mean by this? Well, this is kind of the story of some of this spec that I've been involved with over the last 5 months or so that I think is really cool and is kind of an example of, well, it's just something that doesn't happen very often. You kind of see these new specs spring up to life and get adoption. But as with all good stories, we have to start in prehistory, by which I mean 1989, which is approximately when this promise concept in its modern form was discovered. And one of the people who discovered it was Barbara Liskov of the Liskov substitution principle, and she has some co-authors who I don't remember. Another was Mark Miller, who's on the ECMAScript TC39 committee in charge of evolving the JavaScript language, and he has some other co-authors who I don't remember. But I think it's kind of cool that we have these big names and influential people discovering this concept at around the same time. And in particular, Mark Miller created this programming language, the E programming language, which is focused entirely around concurrency, and it's very much the JavaScript model of concurrency with event loops, but separate event loops that can communicate, but never communicate by sharing data that each can modify in a threaded way. Instead, they communicate by passing messages back and forth. And so the E programming language has a lot of primitives for working with promises. You can just do, basically you can add an exclamation point to any operation, like a function call or a dot for a property access, and it'll do it in a promisey way on objects that you don't have access to yet. But it's a separate story. What I find also interesting is just kind of how this has clearly become the correct paradigm, as you can see by its adoption in so many other languages. So .NET has taxt-t, Java util concurrent future, Python has this Python enhancement proposal, and C++ just in version C++ 11 got std future. Future is just another name for promise. It's confusing. But there's convergent evolution in some sense, or at least some recognition that this underlying concept is exactly what you want for adding asynchronicity into your languages. And in JavaScript, where things really took off, or kind of the first peak of the promises story, is this spec called CommonJS Promises A. And CommonJS was this group of people on a mailing list who thought that it was originally called Server.js. They're like, server-side JavaScript is the new thing, and we are going to be the ones who standardize kind of the common interfaces that all these servers use. And whether that was Node or Narwhal or Rhino or other crazy things. And Node is the only one that's really survived, but some of the things those group did have survived to this day, and whether it be like the module system or the package JSON that we use for Node, or CommonJS Promises A. It was inspired by early implementations. Dojo Toolkit in particular had one. However, the spec had some problems. It was written in 3 or 4 paragraphs of prose, and people only tended to read about one of them. And it had some extra stuff that nobody ever used. It was missing key features that all the promise implementations ended up having. There were things that were just not specified, like it said, when you throw an exception in a promise, then the return promise should be rejected. But it didn't actually say that you should reject it with the thrown exception. So jQuery got a bit confused on that point. And in general, the part about only reading one of these paragraphs applies especially to jQuery. So $.deferred is the next big thing in promises after CommonJS Promises A. Is jQuery in version 1.6, I think, decided to add their own promise implementation. But it's very buggy. It completely misses the entire point of promises, which is this sync async parallel. I think they were just saying, we have these XML HTTP requests, like $.ajax, and sometimes multiple people want to listen to the results. What should we do? Oh, I see, we could have multiple people attach fulfillment handlers. But that's not really the point of promises, is to have multiple listeners. That's more like events, right? So you ended up with this unfortunate thing. So in particular, right, if you go back to those 4 scenarios for the sync async parallel, it only supports the first scenario where you receive a value and return another value. it doesn't handle errors at all. You throw an exception, and it just gives up, puts windowed on error on the task. And it's also not interoperable with any other promise library. So that means when you return a promise from inside a promise handler, it doesn't correctly try and adopt its state, wait for it to finish. And even then, before version 1.8, it didn't have any returning a promise, even jQuery promises. So they finally fixed that, but it's still horribly broken. But we kind of live with that, right? Like, we're like, oh, well, some of us are off using crazy libraries, but some of us are just happy with jQuery and $.ajax and done and fail or whatever. And so it was all kind of quiet until one day on the Ember.js issue tracker, somebody created this pull request, and I happened to see it 6 months ago. A screenshot was taken this morning. It says, add ember.deferred mixin, which implements the promises A spec. However, these were horrible, horrible lies. It did not implement the promises A spec at all. It had no idea what was going on. It was like copying jQuery, but it was even worse than jQuery. And I was like, no, I kind of think Ember might be cool. I can't let this happen. I'm going to get mad and angry on the internet and write a long gist. So I wrote this gist, which made its way around the world, called You're Missing the Point of Promises, which kind of goes over a lot of the stuff we've talked about here, but in a more ranty fashion. Kind of like, here's the fundamental idea of promises, guys. You've got to figure that out before you start using them at all. And so, oh, I'm looking at it over here. Exactly. So yeah. I mean, it's a long essay, and it's a masterful piece of work. But being angry on the internet and writing long screeds doesn't do much. So I decided, like, what if I actually was constructive about this? And so instead, I wrote this promises A test suite. Okay, so it's I put it on GitHub. And I said, oh, I'm going to write programmatic tests for all the points in the specification. And like some of them are underspecified, so I'll include those as like extra tests. Or, and it ended up working really well. So, you end up getting this cool console output, which you can barely see, but you see all those green check marks, I hope. And they're Q, the promise implementation I work on, passing all the parts of the spec. Things like basic characteristics of then. For rejected promises, it must return a new promise and call a rejection callback. Shading off a rejected promise. When the first rejection callback throws a new reason, it should call the second rejection callback with that new reason. It kind of goes bullet by bullet through all the points that a promises thing could do and programmatically test them. And so implementations just kind of gave me this little JavaScript file saying, here's how our promises work, test them for me. And this really kind of sparked something. Like, people started fixing their implementations. Underscore.deferred, which is supposed to be a mainly just a copy of jQuery, fixed themselves. They're like, oh, I want to be promises A compatible. Let me make that work. jQuery didn't, but that's a legacy thing.
They've got their own issues.
Yeah, they've got their own. Indeed. But even more than that, right? Like, then things started getting really cool. And maybe I think this is cool because I'm a nerd. But what happened is, this guy Brian Cavalier, really should learn how to pronounce his name. But he created this gist and invited a few of us to it called Promises A+. And it's just like, let's clarify the Promises A proposal to suck a little bit less and kind of fill in those points that were underspecified and that nobody ever got around to fixing, and just kind of nailed it down in a very bullet pointy way that you can read instead of these 3 paragraphs of prose. If you fast forward, a few months, you end up with this amazing website, Promises A+, with a logo and everything, and it gives this really good systematic definition of how promises are supposed to behave. And what I think was amazing about this was how the process for developing this spec, right? And it's just us. It's just like a few guys who are really passionate about promises and implement promise libraries. We developed this spec, entirely through GitHub. We created a GitHub repo, GitHub organization, which we put ourselves in. We did pull requests against the spec and discussed them line by line. We had all written in Markdown instead of, I don't know, whatever they write specs in these. That crazy IETF thing, right? Like where the pages are. Anyway, it's like 8.5 by 11 on the internet. Anyway, we had random people from the internet stopping by and opening issues on the spec, saying, "Hey, I think this is unclear," or "Hey, I think my implementation doesn't work like this. What do you think? Can we fix that?" And we came to consensus over time, and it really ended up working really well. And of course, we had an amazing test suite, right? Like I expanded the original test suite, which was something like 40 tests, to something like 320 for the Promises A+ spec. Because if you want to make a spec, it needs to be like that. And I think it's been a real success. So we kind of track all the conformant implementations that we can track down and put them on this GitHub page. And there's more than 20 now. I kind of notice a new one just popping up in my NPM feed every day because whenever you put out a test suite and a spec, people really like to implement it. It's like a challenge. In particular, one I'm really impressed with is somebody wrote it in ActionScript 3, which is this crazy bastard dialect of JavaScript meant for Flash. But they wrote it, and it passes the test suite somehow. So awesome. And if we go back to the Ember story that started all this, Yehuda Katz created rsvp.js, which is a new promise library. It's very prominent because he's a fairly prominent guy, specifically so that Ember could have Promises A+ compatible promises. I mean, we kept working on this. We're working on version 1.1 of the spec, which has some clarifications around interoperability and edge cases and unspecified points. We want to make this as rock solid as we can. And we're working on sibling specs for things that kind of, it would be nice if everybody was on the same page for. Things like how you create a promise and how you cancel a promise, as we were discussing earlier. Or let's say if we want to have progress events, so you're doing a file upload, and you want to kind of, even though we're not sure if progress is a good idea, to be honest, because it doesn't have a synchronous parallel at all. But then again, neither is cancellation. But you might want to get progress on your asynchronous operation. And even more than this kind of like community activism and people conforming to the spec left and right and writing new implementations, we've got the DOM and T39, the committee in charge of JavaScript, are getting in on this bandwagon. So Alex Russell, who's on the Google Chrome team, he wrote this DOM future promise library as an envisioning of what promises could look like in the DOM. So things like XML HTTP requests could actually return a promise, or IndexedDB could be made a lot less horrible by returning a promise, or geolocation, or all these other things where in the DOM you get these weird patterns where there's these objects that have success and error events that can only fire once, and only one of them can fire, but they're still events, so you do like on success equals, and then you try and delete it so you don't leak memory, and it's ridiculous. Whereas what you're really talking about is a promise, right? You have two things, and you want to be able to chain them and treat them in all these beautiful ways. So DOM future is kind of his idea of how this is going to work in the DOM. I mean, Mark Miller, who I mentioned earlier, he's had this idea for a while of adding promises to the language, and we've totally converged. We've said, oh, well, Promises A+ is exactly the baseline that we need for this. So he has this straw man, as they call it, like a straw man proposal for adding things to JavaScript for concurrency in general and for promises in particular that just converges perfectly with Promises A+. So that's the story. I'm happy with that. And finally, I wanted to spend a little bit more time being practical, right? So we took an intermission to talk about how cool all of this was. But if you were to start using promises today in your code, like what are some of the things that I think you should be aware of? And this isn't like, basic 101. This is more like overall things to keep in mind. So the first thing you have to do, of course, is choose a library because they're not in the DOM yet. They're not in the language yet. My favorite, of course, is the one I work on. It was actually Chris Kowal is the originator, and he derived it from an earlier code base. But I got obsessed with this stuff. He just added me as a contributor one day, and we've been working together on it since. It's really powerful. It has a large API surface, adapters for Node.js. It has progress support, long stack traces. It has some really cool stuff about like promise pipelining across remote objects, which I'll talk about later. But also, just to give other libraries a fair shake, some of the others that have a lot of popularity and are pretty decent are when.js by the guy who started the whole Promises A+ thing, Brian, and rsvp.js, of course, the new upstart from Yehuda. And then the most important thing to do once you have a library is that if you ever see a jQuery promise, you need to kill it with fire. And by fire, I mean functions like q and when, which just absorb jQuery promises and turn them into real promises. So, you do $.ajax because that's convenient, okay, but the moment you do that, wrap it in a queue so that you get a real promise back, and then you can chain and get errors in a sane way and get only one return value instead of XHR, status, data, whatever. All right, so the other piece of guidance, and this is kind of the overriding one, I was kind of touching on it earlier, is when you're writing promise-based code, you want to keep the sync and async parallel in mind, right? So you want to use promises in particular for operations that can result in a fulfillment or rejection, just like functions can result in a return value or a thrown exception. If you're ever stuck, you want to say, how would I do this in sync code? Like, would I write this as 3 things in a row and then a catch, or would I, do these 2 things in parallel but then have to combine them because that's the exception, right? But then you move on and you do a kind of a synchronous flow from there. You can always kind of draw an analogy and say, what would this look like in synchronous land? And I think that's part of the power of promises. Is unlike these other callback aggregator solutions where you're like, oh, is it an async.series or an async.waterfall or an async.map? Like, you just say, oh, what would it look like in sync code? But on the subject of async sync parallel, you have to keep in mind things that promises are not, right? There's still asynchronous stuff out there that promises are not a good fit for. So they're not a replacement for events, right? An event is a very different thing from a promise. Like, promise is like an asynchronous operation, function call, say. An event is something that could happen multiple times, synchronously or asynchronously. People could be listening to it, unsubscribing, resubscribing, doesn't matter. They're not a replacement for streams either. If you're familiar with those from Node.js, the idea is you get a bunch of data pushed to you, or you pull a bunch of data down the wire, or you write a bunch of data to a file incrementally. And the idea is you can pipe 2 streams together and say, oh, I've got an HTTP request incoming, I'm going to write that to a file stream, and it just all goes through. Promises have nothing to do with that. That's a completely different paradigm for data flowing through a pipe, essentially. It's not about a single asynchronous operation. And finally, some people are really into functional reactive programming these days, and this is like crazy stuff about like sequences of observables and like RxJS, if you've heard about that. I don't think promises fit in very well there. I think that's a bit different of a model. I'd be curious if you could merge them, but I don't think they do. But I'm not saying abandon promises for all these things. I'm saying they can work together, right? So if you have an event that triggers an asynchronous operation, that makes perfect sense. You click a button and it calls a handler that then calls a promise returning method for posting to the server. And then you do your whole UI show error, UI show result thing. They work together. And similarly, like, if you want to do a stream, like, you can do a promise returning function that asynchronously sends off a request and gets fulfilled with the response stream, or rejected with whatever error came down the pipe, right? So you can get a promise for a stream of data, and that's totally fine, because getting a stream is often asynchronous. So yeah, that's the guidance, but here's the pitfall. And this is kind of the dirty secret of promises. And it makes sense when you think about it, but it catches people by surprise, so I really wanted to include it. So if you are in this synchronous situation, right, you're just writing code, and the only thing in your file is throw new error. That will show up in your console, right, because nobody's catching it. It just hits the top level, it hits window.onError, or it crashes your node program, or whatever. But if you're in a promise situation, right, and you are coming back from a promise, and then you throw an error inside the handler, what that does is it creates a new rejected promise. It doesn't bubble up to window.onError. It doesn't bubble up anywhere, because we don't know. You might handle that later. You might say, oh, promise.then, undefined, handle error, or promise.then, handle success, handle error. We can't know when you're going to handle that. So if you're not careful, you can end up with rejected promises in your system that nobody knows about because you never attached an error handler. Now, I'm not saying you should go back to the old days of always insert an error and a success. That's not what promises are about. But I am saying be aware of where your chains are and kind of make sure you end them correctly. And the golden rule that we've kind of come to is we have this new function called done, which you put at the end of a promise chain. And so you say, like, well, we'll get to the example. And so you either say, I'm going to take this promise and return it to my caller, so I'm not responsible for it anymore. I'm part of a chain. Or the chain stops here. I'm done. We're not going to do any more asynchronous processing. I'm going to call done and signal that to the promise mechanism so that it knows, oh, nobody's going to handle any rejections here. Let me throw them and crash the program or window.onError or whatever. So in particular, right, like here's an example of both of these. So we have this getUsername function, which does kind of the functional transformation idea. It gets the user asynchronously, and then it grabs its username. And this is fine. We don't need done here because we're just returning the promise. We're like somebody else will handle consuming this and saying they're done with it. Well, that somebody else is exactly down here, right? They get the username, and then they log it, but then we call .done, because if there was an error getting the user, or pulling off the name property because the user was null, or logging to the console because you're an IE7, then you call done and you say, oh, I don't have any handler for that. Throw it. Don't leave it there hanging in the return value that nobody saved. So that's the pitfall.
So is then functionally equivalent to having another then that just returns the value straight through success, or fires the error, or is there more magic inside of it?
Pretty much. It would, yeah, that's pretty much how it's implemented. Is on error, it just does like a process next tick or a set timeout 0 to throw the error so that the promise machinery doesn't catch it and transform it into rejection. It just ends up on your console. Yeah, that's exactly it. All right, now just getting into a series of promise patterns. And a lot of these are kind of queue specific because we add a lot of sugar to make your life nicer. But, I think they're really cool. So, if you have a try-catch finally synchronous code, you can emulate that exactly with these helpers in queue. So you start the spinner, you get the user, then you get his best friend, then you show his best friend, and if any of those steps error, you do the UI error, and finally, whether there was an error or not, you can stop the spinner, and then of course you call done. So catch is a very simple sugar. It just doesn't have a first argument. It's like then without a first argument. Finally is a bit more complicated because it does things like, oh, if there was an error, then do this, but also pass through the error. If there wasn't an error, do this, but pass through the result, that type of thing. But it's basically the idea is, you execute the same thing whether it's rejected or not. Another pattern that I see a lot, well, and that I think is a cool queue feature, really. So we talked about all, the idea that you could do multiple operations in parallel and get the results as an array. So this is what it looks like in its raw form, right? You get the user, you get company, and you get the results array. And then you're like, oh, here's the user, it's result 0. Here's the company, it's results 1. Well, it'd be kind of nice if you had nice names for those instead of just looking back, oh, 0 is like the 0th position here, 1 is like the 1th position here. Not so great. So we created this function called spread, which is just a version of then, which spreads out the arguments of an array over the result. So you say, oh, user is the 0th element, company is the 1st element, and you get these nice local variables that you can use. So queue and all and spread work well together. This pattern I see a lot in our code base and in every code base I've ever written with promises. So you have an array of things, like say user IDs or whatever, and you want to do a bunch of asynchronous operations based on those. So you map those user IDs to promises, right? So getUserById is a function that returns a promise. So that map call returns an array of promises. You do queue.all on it to say, oh, wait for all of those promises to be done, and then you get all your results. So that's a pretty common pattern as well. Finally, well, we've got this one other pattern which I think is well, this is very unique to queue. I've never seen anything else that does this. But it's really interesting. So the idea is that we allow you to queue up operations that happen on a promise even before the promise comes back. So it's really kind of sugar in some sense, but we'll see later how it's not. So you get the user data promise, and then you create the view model, which say that returns a promise for a view model. Well, then we call this queue function called invoke, which calls the setStatus method on the user view model with the string loaded. So the idea is like that will wait for the user view model to come back, which means it waits for the user data to come back, and then call a method on it. It's a nice sugar. Similarly, you have the get data. Well, we have this get function, which pulls out properties, right? So you get their friends, and you get the 0th element of the array, and then you get the name property of that friend, because these are all returning promises for the result of doing whatever that operation was. And now you have the friend's name, so you set their best friend's name in the UI. So it makes for some really nice, concise code that doesn't kind of have to do lots of transformations in an intermediate way. The final pattern is denotify. So if you work in Node.js, you have all these callback functions that make you sad because you're like, oh, I have to explicitly handle errors all the time. But you can just denotify them. And once you do that, you're good to go. You say, oh, I'm going to read this dir, and then I'm going to use my sugar I just showed you to get the 0th entry in the array. And then I'm going to call read file, which takes as a parameter a string of the file to read, but it returns a promise now that I've denotified it. And then I get the data, so I can output the data to the console. Or I can catch the error, and I can say, oh, well, one of these steps failed, probably read dir or read file. and I'm ready to output that to the console. All right, so advanced promise magic, bonus round. You guys made it to the bonus round. So there's a few really cool things you can do with promises. There's two. The first is about this upcoming language feature, which is based on a concept called coroutines. And the Wikipedia definition is it's a generalization of function calls where you can enter the function like normal, but then you can also exit it and come back in where you left off, and do this over and over. And in particular, the next version of the language is going to have something called generators, which are actually shallow coroutines, meaning you can't, well, they're a limited form of coroutines. So here's an example of using them for non-promise purposes, right? Where this is a function, function star for generator function, which returns an infinite sequence of Fibonacci numbers. And it does this by this new keyword called yield, which says, oh, it's like return, but then next time you call the function, it's going to come back and start off like here, and it's going to go, oh, I'm going to do that, and then I'm going to yield the next version. And then I'm going to come back, and I'm going to go here, do that, yield the next one. So you continue calling this function, and you re-enter it at this point that you left off. And so how this ends up working is, you loop through the results of this function. And there's some magic like about how lists and functions that return multiple values are kind of the same thing. But bear with me. And you can log an infinite sequence of Fibonacci numbers with an implementation like this. So that's pretty cool. And you can kind of see how this might be useful for promises, maybe. So there's this library called task.js, written by David Herman, who's on the TC39 committee again. And it ends up making your code look like this. So it works with any kind of promises, even jQuery promises. You say, yield on this promise. And it'll exit your function while it goes off and does that thing. And then when that data is ready, it'll come back, stuff the result in data, and then move on. So it sets the result, and then it sets the HTML. And then it yields on like this fade-in promise, which is a jQuery thing that says, oh, give me a promise for when this is done fading in. So then it exits your function, and comes back in. And then it sleeps for 200 milliseconds, so it exits your function, comes back in, and does the fade out. So this is pretty sweet. And what's even sweeter is that this works with exceptions too. So it transforms rejections into actual synchronous exceptions. So you can get all your control flow constructs back, the normal ones, just by putting this yield keyword in front of your promises. So here's an example with try catch to show the error, and you update the user. That's it for task.js and generators, but I think that's pretty sweet, and I'm really looking forward to that. It's almost in V8, which means Chrome and Node.js, and it's kind of in Firefox, but it's buggy. All right, last thing, remote promises. So remember this example where we got a user, we got their friend 0, and then let's say we invoke a method on that 0th friend, like calculate their friendship coefficient, and then we display it in the UI. What if user promise represented a remote object? What do I mean by that? I mean an object that lives on some other server and has methods that live on some other server, and you don't send all that over the wire, you just pipe messages to that remote object, and you get a promise for the result. And this is realizable with a library called QConnection. So in particular, it connects to web workers, iframes, or web sockets. So you can talk to other servers, you can talk to workers if you want to do a lot of computational intensive stuff, or you can talk between domains with iframes or whatever. So you just set it up like this, and now you can have this remote source of promises that you get promises from, but those promises now represent remote objects. All right. Yeah, it's better than all the existing systems, and promises are awesome, and you should use them.